All right, welcome back. So last time, we zoomed out and got the big picture of AI. Today, we're going behind the scenes. We're stepping onto the training ground to see how these machines actually learn to be so smart.
So let's just start with the biggest question of all, right? How in the world do you teach a machine to think? Because it's not about just writing a giant list of rules anymore. It's about creating a student that can figure things out for itself.
And just a super quick refresher from last time, remember our simple breakdown. Artificial intelligence, that's the big goal. Machine learning is the process we use to get there. And deep learning, that's one of the most powerful techniques we've got.
Okay, so for this whole explainer, I want you to hold on to one big idea, one metaphor. Just think of the computer as a student. It's basically a blank slate, totally ready to learn, and our job is to figure out the best way to teach it.
And you know, just like any student, there are a few different ways to learn. Different classrooms, if you will. We're going to walk through the three main ones: learning with a teacher, learning all on your own, and finally, learning by doing. Let's start with the most popular class in the school.
So here we are, classroom number 1, learning with the teacher. This is by far the most common way we train AI models today. The official name for it is supervised learning. And the name says it all, really. In supervised learning, the student, our machine, gets a massive amount of study material, but here's the kicker. It also gets the complete answer key. Every single piece of data is already labeled with the right answer.
The absolute best way to picture this is probably something you've done yourself. It's like studying for a big test with a giant stack of flashcards. You've got the question on one side and the correct answer on the back. You just drill them over and over and over again.
So, how does this work in the real world? Well, let's take the classic example. Teaching an AI to tell the difference between a cat and a dog. We feed it thousands, sometimes millions of images, but every single one is carefully labeled. Cat, dog, cat. The machine churns through all these examples until it starts to recognize the patterns on its own. You know, pointy ears, whiskers, floppy ears, snouts. Okay, let's head over to our second classroom. Now this is where it gets interesting, because in this room, the teacher leaves. This is learning on your own, or as the pros call it, unsupervised learning. It's all about finding patterns with zero help. So, in this setup, we give our student a massive, messy pile of data. But this time, there are no labels, no answer key, nothing. The machine's only job is to stare at all this chaos and try to find some kind of structure, some hidden groups or patterns, all by itself. To get a feel for this, just imagine I handed you a giant basket filled with all kinds of different fruit. I don't tell you what they're called, I just say, hey, sort these. You naturally start making piles, right? Based on things you see? And that is exactly what the machine does. It has no idea what an apple or an orange is. It doesn't know our words for them. So instead, it makes up its own categories based on similarities. It might decide, okay, here's a pile of red things, or here's a pile of things that are small and round. It discovers the structure all on its own. All right, time for our last stop, classroom number 3. This one is less about studying data and more about just getting out there and doing stuff. It's learning by doing, basically a long process of trial and error. And we call this one reinforcement learning.
So here, our machine is more like a player in a game. It has a goal it wants to achieve, and it learns by just trying things. The real magic is the feedback. When it does something that gets it closer to the goal, it gets a reward. When it does something bad, it gets a penalty. Simple as that.
The perfect way to think about this is learning to get really good at a complex game. Maybe something like chess. Nobody hands you a book with all the perfect moves. You learn by playing, game after game after game. You try stuff, you see what happens, and eventually you develop an intuition for the best strategies. Let's break that chess example down. The goal is simple: win the game. Every time the AI makes a good move, one that improves its chances, we give it a little reward, like a point, a digital pat on the back. But if it makes a bad move, a blunder, it gets a penalty, a negative point. By trying to maximize its score over millions of games, it eventually teaches itself how to win. So our student has made it through 3 very different kinds of school. It's graduation day. So let's bring it all together and see how these different learning styles stack up against each other. Let's recap. First, you've got supervised learning. That's our flashcard student, learning from labeled data with all the right answers. Think of your spam filter. It learned what spam looks like from millions of labeled examples. Then you have unsupervised learning, the explorer, finding hidden patterns in unlabeled data, just like sorting fruit. This is how streaming services can recommend a show you've never heard of. And finally, reinforcement learning, our game player, learning from rewards and penalties, trial and error. That's how AIs master chess or learn to control a robot arm. 3 very different students, 3 different paths to getting smart.
And really, that's the bottom line. Whether it's following a strict answer key, making its own discoveries in a pile of chaos, or learning from its own mistakes, the end result is the same. We've managed to turn a machine into a student.
But, that brings up a really fascinating question. We've just spent all this time talking about how our student learns, but we haven't talked about what it's learning with. So next time, we're going to peek inside the student's mind.
So I'll just leave you with this to think about. We've covered the how, but what about the what? What is the actual structure inside the computer, the digital brain that's processing the flashcards, sorting the fruit, and playing all those games of chess? We'll get into all of that next time.